Hello, this talk is by Sue and Les Knight and it's on the lichens of drystone walls in Swaledale. So what's a drystone wall? A drystone wall is a wall built without the use of any cement or mortar and used to surround a farmer's field. Where's Swaledale? Swaledale is in the north of England in Vice County 65, which I've shown as a dark line here. It's the northernmost of the Yorkshire Dales and extends east from the east in the Vale of York up to the High Pennines, where it overlooks the Vale of Eden. To the south is Wensleydale, and to the north is Teesdale. Here's a typical picture of the valley itself. You can see that the limestone or the walls are an iconic component of the whole of the landscape. You also notice that there are relatively few trees to be seen or hedgerows, and that the walls themselves are the main substrate for lichens in the area. Geologically, the area consists of a series of alternating limestones, mudstones, sandstones, limestone, mudstone, sandstones up the hill until you get to the intake, where that's the highest wall, and above that is acid moorland on the millstone grit. The moorland's used for grouse shooting, the rest of the intake is used for sheep and cow arable farming. Now, this looks like an idyllic scene, but actually it's an area of or it's a post-industrial landscape. From at least Anglo-Saxon times up until the 1890s, there was lead mining and, more importantly, significant lead smelting in the area. So you have to imagine at times that the atmosphere must have been full of sulfur dioxide and its associated acid rain. As an indication of this, some time ago we did a survey of Rhizocarbon geographicum on gravestones. And what we did was we measured the diameter of each of the Rhizocarbon geographicum thalli on every gravestone in Swaledale and its associated valley, tributary valley of Ark and Garthdale, and plotted up the results. So here we're plotted from 2020 back to 1760, and then vertically these are all of the different thalli, the diameter of the thalli that we found. And surprisingly, or surprisingly to me, we got a really good straight line growth curve of 0.6 millimeters a year going back to about 1860. But beyond 1860, the lichens were all much smaller than you would expect it, or simply weren't present on the gravestones at all. And this we attributed to the effect of smelting and mining at the time. As a matter of interest, none of our drinking water and none of our streams or rivers can be used for drinking water. They all exceed the drinking water standard by 6 to 10 fold, and all of our water has to be pumped into the valley. Anyway, moving on to the topic of the drystone walls themselves. We looked at the spatial distribution of the lichen diversity, on 148 drystone walls in the Vice County. They're predominantly in Swaledale, but some were in Wensleydale and one or two towards Teesdale itself. And really what we were trying to do was find out what determined the variation in the diversity. We took a 10-meter length of wall and we measured the position of the wall and hence its elevation, the orientation, that's the direction in which the wall faced. We measured both sides of the wall. And also the percentage limestone and sandstone, because the walls were often made of a combination of both. Whether there were any bryophytes, there's a rough guess of the percentage and that of algae, and whether the wall was enclosing pasture or was facing or on the open moor. I have to just emphasize the extreme environment that these walls are under. They have zero shade. And even in the valley, we've measured temperatures from -20 to +40 in the 10 years that we've lived there. The rainfall just never stops. It's between 1.5 and 2 meters. That's some 60 to 78 inches of rain. And we've seen snowdrifts over the top of the walls. And there are frequent gales. So it's an extremely hostile environment for these lichens to grow, but they do grow very well. So we first of all look to see whether there are any topographic controls on the diversity of lichens. And here we're plotting the species diversity on a wall versus elevation. And the lowest elevation was about 160 meters up to the highest, which was 600 meters, 2,000 feet. And I don't think you can see any variation, which was a surprise, but that seems to be the way it is. However, the rows diagram shows the diversity of lichens as a function of the orientation of the wall, the facing wall itself. And here is a very, very clear preference for south and southwest facing walls. Lichens do like those. North facing walls have many fewer lichen species, probably because they're much more shaded, they're damper, and have more algae and more bryophytes present. We also looked to see if there was any control in the land use, and so we compared the walls that were on open moors versus those that were in the enclosed pastures. So the open moors, they're subject to periodic controlled burning, whereas the enclosed pastures are subject to manuring, but not very controlled, natural manure only. We found 123 species on 61 walls in the open moorland and 129 species on 87 walls in the enclosed pastures. So there was a very similar species diversity. However, there was only about 68% of the species were common between the two environments, which is somewhat surprising. So we're not really clear what impact, if any, the different type of land management had. However, anecdotally, we can say that while we didn't measure the diversity in farmyards or very close to farms, just the visual examination suggested that because of the increased sheltering from trees and shading, they tended to be much richer in bryophytes, and also probably the lichen diversity was affected by the higher nitrogen that you would find. However, the biggest control on lichen diversity was the substrate itself, whether you were talking about a sandstone wall or a limestone wall. But remember that many walls actually contained a mixture of both. On the sandstones, we found 110 different species, and on the limestones, 58, with only some 10% overlap, which I've tried to show here. So basically, it's the chemistry of the wall that determines the species diversity itself. Just taking the top 5 in each of the environments, and I'm going to use the old names if you don't mind. For sandstone, they were Porphyria tuberculosa, Parmelia saxatilis, Lecanora sorolifera, Acarospora fuscata, and Rhizocarpum geographicum. But note, even the commonest, which occurred on 86% of walls, had Porphyria tuberculosa. There was never a case where a particular species was ubiquitous, which is a little surprising. The limestone walls, Verrucaria nigrescens appear on 86% of walls, and Caloplaca flavescens, Aspersilia calcarea, Protoplastina rupestris, and Aspersilia contorta were the other common species. But again, there was never an instance where even Verrucaria was ubiquitous. So why were no ubiquitous species? Well, one possible explanation might be that by just using a 10-meter sample length, we weren't looking at enough of a wall. Perhaps if we'd extended to 20 meters or more, we might have found a ubiquitous species. But I'm not entirely certain about that, because even these 5 commonest species, I don't think we found a wall where all 5 were present. And particularly Acarospora fuscata and Rhizocarpum geographicum tended to be very choosy on the particular sandstones that they were growing on. Just some examples. Sandstone wall, so we have Rhizocarpum geographicum and Acarospora fuscata, Porphyria tuberculosa and Lecanora sorolifera. And some limestone walls, Verrucaria nigrescens and Caloplaca flavescens and Aspersilia calcarea. But there's a whole suite of wall top specialities, of which Pseudovernia furfuracea is a really common species growing right on the very tops of the walls. We found both chemotypes. And of course, there were many different types of Cladonia gardens growing on the tops as well. We also found Umbilicaria polyphylla and Parmelia omphalloides as examples of wall top species. Another thing we looked at was there any difference between the lichen diversity on the limestone outcrops or quarry faces versus the limestone walls? And here we have a quarry, and you can see the original outcrop is on the top here. Remember, this has been exposed for 10,000 years since the last ice age, whereas the face here has probably been only exposed 100 or 200 years since it was quarried for the limestone to build this wall, which is only some 20 meters away. But the thing about the Carboniferous limestone, it is really quite tough, quite solid, and they are quite disappointing, the quarry faces themselves, in terms of their lichen diversity. You can see there are relatively few lichens growing on the surface. However, you do get the occasional Solarina and Toninia, which are sort of specialist crevice species growing there. And we've never found those on the limestone walls themselves, even though you might think it's just a whole mass of crevices. There's something that prevents them taking hold. Perhaps there isn't enough soil for them to anchor in or something like that. But basically, there tends to be, what have we got? Less diverse. The walls have a higher diversity than the adjacent limestone outcrops. But one of the interesting features is that we did find that the walls were refuges for various typical Corticulous lichens, normally only found on trees. And here's an example of Bryoria fuscescens, which is of only least concern in terms of its conservation status, but for us is unbelievably rare. We've only found it on 4 occasions, 1 on a tree and 3 times on walls. Maybe it was more common in the past. But I'm just intrigued by why this should be flagged up as of least concern. But here's a sort of distribution map of Bryoria, and this is the red spot in our Vice County, the ones we found, and we're right on the southern limit. So okay, it's maybe of least concern if you consider the whole of the United Kingdom as a whole, but for us in our Vice County, this is an extremely rare species, and I don't think the current designations are entirely appropriate on a scale of a county or more. Perhaps we should consider how we actually derive these designations. Another example of a species that's moved from a tree to the wall is Anaptychia ciliaris, which has a whole range of conservation statuses indicating this is nationally scarce and it's endangered. But for us, we found it relatively frequently. We found it on 13 locations, all of them on limestone walls. It's not common, but it's certainly much more common than the Bryoria, which is flagged up as of least concern. And here you can see that we've made quite an impact on finding it on limestone walls in Viscounty 65. I wouldn't be surprised if people looked in the Southern Lake District here and in Lancashire and in Southern Yorkshire, whether they wouldn't still find it if they looked on the walls themselves. And then lastly, here's a picture of a mature, mainly sandstone wall, in which you can see a number of small microhabitats. And this I hadn't noticed before, but underneath these horizontal slabs, the so-called throughs, this obviously protected, sheltered the area underneath, because these sandstones are completely free of lichens, presumably because it's just too dry. And as soon as you go further down or further up, you're into an area where there's enough water to sustain the lichens themselves. And you've also got a little plume down here where there seems to be much more algae than there were in the areas to either side. One of the features of Swaledale is that it's very isolated. There's only one route into the valley, which doesn't involve hairpin bends and a 1-in-4 slope. And the result is that it's maintained its historic dialogue known as Swaledale. And Swaledale is the local name for the River Swale. And we were once looking at one of these walls, and one of the native Swaledale speakers came up to us and asked why on earth we were wasting our time looking at stains on stains. Thank you.